Okay, in this video we will go over Wronskian determinant pair of functions. And so if the Wronskian determinant of f and g is t squared times e raised to t and f parentheses t is equal to t, we want to find gt. And so we're given the Wronskian determinant already. And we just wanted to know g. So we can say f g, so f prime g prime is equal to, we're given f as equaling t, and so f prime would be the derivative of t, so simply 1. We want to find g, so we can say g prime is equal to t squared times e raised to t. So we'll do t times g prime minus 1 times g, so g is equal to t squared times e raised to t. And so next we're going to want to have this in standard linear form, so we'll divide by t, and divide by t. So we'll get g prime minus 1 over t times g is equal to t times e raised to t. And so the next thing we're going to do is get mu. We say, so the integrating factor. So mu would equal e raised to the integral of negative 1 over t, this value right here, dt. And so we can say that e raised to negative ln t, which is the integral of negative 1 over t. And so we can break this down even more and say e ln t raised to negative 1. This would cancel out e ln, so we would get t raised to negative 1. T raised to negative 1 is equivalent to 1 over t. And so now we multiply our integrating factor by our standard linear form. So we would get t raised to negative 1 times g prime minus t raised to negative 2 times g is equal to et. And so we will do this right here will equal parentheses t raised to negative 1 times g, and the prime sign is on the outside, so this, but the prime sign instead will be on the outside, is equal to et. And so the next thing we do is take the integral of this, and so the integral of this is pretty easy because the prime sign is on the outside, so it's simply going to be t raised to negative 1 times g, and the integral of e raised to t is also easy, simply e raised to t plus arbitrary constant c. And so the last thing we do is divide by t raised to negative 1 to get g. So g is equal to t parentheses e raised to t plus c. And this right here is our final answer for g. And that's all we need to do.